But I want you to notice one more thing about this graph. I've removed the lines I had on there when we were doing dominance reasoning. Notice something else. A second point on this graph is also in Nash equilibrium. This point, R3C3, is also in Nash equilibrium. If the players hit this particular point, neither will have any reason unilaterally to change. Rho has no reason to change, to go to R2 or R1, because that would be giving up. That would be going to a +1 instead of a +4, and be going to a +4 just as a tie to +4. So if they get on this point, Rho has no reason to change. Column certainly has no reason to change if they get on this point. This point, it would go from -4 to -6, -4 to -5. So this point here is also in Nash equilibrium, and if you check it out, you'll see that it also passes the minimax equilibrium test. It is the minimum value for rho in this particular row, and also the maximum value in this particular column. And it also meets the security level test. If rho chooses R3, the worst rho is going to do is +4 as opposed to +1 or +4. And if column chooses C3, the worst column is going to do is -4 as opposed to possibly doing -6 or possibly doing -7. So this particular table has 2 points that are in Nash equilibrium. So notice that it is possible for decision tables to have more than one point that is in Nash equilibrium. So there actually is a second solution to this game. It's the R1C3 solution. There's also the R3C3 pair, and it also has a value of equal 4 for rho. So, in the first table we looked at, there was only 1 point in Nash equilibrium. There was only one solution to that particular game with its particular value. This game has 2 separate points in Nash equilibrium. So there are 2 separate solutions to this game, and notice they have exactly the same value. 4 for rho, -4 for column. Yes?
I have a question.
Yes?
I can understand why C3 is always going to choose, I mean, my column is always going to choose C3,
Right.
but what I cannot understand is after rho has evaluated 735 and has eliminated R2 and R3, what could conceivably make rho choose R3 as opposed to R1?
Excellent. By dominance reasoning, remember, rho would choose R1 because it actually weakly dominates C3. So if rho just used dominance reasoning, rho would automatically choose R1, column would choose C3. But notice that there is still another point on this particular table, which is also in Nash equilibrium. If they got onto this particular point, there's no reason for either to universally change. So dominance reasoning would reveal R1 to be the preferable choice by rho. But there's actually 2 points in Nash equilibrium in this, and notice the important point is they have the same value.
Is that it?
Mm-hmm.